जी मुझे बताएंगे फील्ड क्या होती है? सो फील्ड के बारे में मुझे बताएं। फील्ड इज ऑब्वियसली सेट ऑफ स्केलर्स। स्केलर क्या होता है? इट इज़ एन एलिमेंट ऑफ अ फील्ड, बट फील्ड इज अ set with a particular property. So first of all, it is a set, and this set has two operations. One operation we call plus, another operation we call multiplication. Two operation. So set with two operations. और ये दो ऑपरेशंस की डेफिनेशन आपने देनी है, यानी आपने ऑपरेटर ओवरलोड करना तो आप कर लें, एज लॉन्ग एज ये दो ऑपरेशंस इस सेट के एलिमेंट्स पे कुछ प्रॉपर्टीज़ हैं, अगर वो सेटिस्फाई करें तो देन ये सेट फील्ड कहलाएगा, अदरवाइज नहीं कहलाएगा। ठीक है, तो वो पहली प्रॉपर्टी क्या है जी, बताएं। क्लोजर अंडर व्हाट? क्लोजर अंडर एडिशन, क्लोजर अंडर मल्टीप्लिकेशन, देन जी एसोसिएटिविटी, कम्यूटेटिविटी, एसोसिएटिविटी क्या होती है बताएं? बताएं थोड़ा सा। let's say the set we are targeting is f. So if a belongs to f and b belongs to f, then a plus b is equal to b plus a, and मल्टीप्लिकेशन में है a star b is equal to b star a. Okay, anything else? Associativity जी, if a, b and c, then a plus b plus c is equal to a plus b plus c. A star b star c yes. Anything else? Additive identity. There is an element in f called 0. That 0 doesn't mean 0 number. Whatever that set is, whatever those objects are, in those objects there is a particular element which we denote as this, and we will call that 0. That is not a 0 number, that is an object, but that object has this particular property. For all a in f, a plus that number stays a. That is called additive identity. Similarly, multiplicative identity. There is an element called 1. It is called 1, it is not number 1, it is called 1. That object has name 1, such that for all a in field f, a star 1 is a. Anything else? Additive inverse, multiplicative inverse. Oh, what is that? Additive inverse and multiplicative inverse. Additive inverse. For all a belongs to f, there exist multiplicative inverse. For all a in f, there exist for all non-zero A. If these properties are there, if these 8 properties are there in any set, or you can make them appear in any set, you define your operator plus, you define your operator steric in a way that these properties start holding in a set, then that set is called a field, and the elements in that field are called scalars. सही है? अगर हम देखें तो रियल नंबर्स का जो सेट है उसमें ये सारी प्रॉपर्टीज़ मौजूद हैं. रियल नंबर्स का अगर आप सेट देखें तो रियल नंबर्स आर क्लोज्ड अंडर प्लस. द प्लस इज़ ऑर्डिनरी प्लस, जैसे 2 रियल नंबर्स को ऐड करते हैं. द स्टेरिक इज़ ऑर्डिनरी स्टेरिक, 2 नंबर्स को जैसे मल्टीप्लाई करते हैं. सो द रियल नंबर्स आर क्लोज्ड अंडर प्लस. रियल नंबर्स के लिए प्रॉपर्टी 1 चेक्ड, क्लोज्ड अंडर स्टार चेक्ड, commutative associative checked. There is an element called 0, that's literally the 0 element, that is there. Literally the 1 element, that is there. For every element there is a additive inverse of it. So whatever you element you come up with, flip its sign and you get the additive inverse of it. So it's closed under additive inverses. And for every non-zero element, it's closed under multiplicative inverses. So the set of real numbers is a field, so every real number is a scalar. The same is true for the set of complex numbers. The set of complex numbers also with ordinary plus and steric definition. The way you multiply 2 complex numbers, the way you add 2 complex numbers, the ordinary definition. With that definition, you can see all these properties, they exist in the set of complex numbers. So the set of complex number is also a field, and so every complex number is a scalar. Okay? Make sense? Now what's a finite field? That's interesting. A finite field is a field with underlying set being finite. Which means if this set is finite, if you have a finite set means the total number of elements are not infinite, finite set. If you have a finite set and you have all these properties available in that set, that is called a finite field. Okay? Example. This is a field 0, 1, and the plus operator is overlaid as follows: plus AB. This is the definition of plus I am giving. Whenever you want to add 2 objects from this, I am overloading the definition. I am overloading the plus operator. Plus AB is ordinary A plus B mod 2. Ordinary A plus B mod 2. Okay? Where 2 is no longer a number in this field, 2 is integer. Okay? That's my plus operator, and my star operator is the following. It's simply A star B, the simple operator A star B, like ordinary 1. Okay? Now with this plus and this star, we can see all the properties they exist. This set is closed under addition. Yes, no? Yes, because 0 plus 0 belongs to F. 1 plus 1 is equal to 2, but 2 mod 2 is 0. So 1 plus 1 is 0, which belongs to F. So with this definition of plus, it is there. 0 plus 1 is 1, that belongs to F. And then, I mean, this is closed under addition. It is closed under scalar multiplication. Yes? Sorry. It is closed under multiplication. You can see. What's the next one? Commutative. It's commutative. एसोसिएटिविटी इसमें है नहीं क्योंकि तीसरा एलिमेंट आप बहरहाल वो लगा लें तो आ जाएगी एसोसिएटिविटी भी. What is the zero element? Here the zero element, we denote zero element as this one. This is the element 1. So zero element is there, which is called additive identity. Multiplicative identity is there. Anything else? Additive inverse. Do we have additive inverse? Yes. We have additive inverse of every number. The additive inverse of 0 is 0. The additive inverse of 1 is what? What is the additive inverse of 1? What should I add it so that it becomes 0? 1. Yes? So the additive inverse is there. Multiplicative inverse for non-zero elements. The non-zero elements is this. So multiplicative inverse of 1 is 1. Yes? So this is a field. Make sense? Yes, no. That's a finite field. We can have other examples of finite field also. Can you check, for example, here, this set. Can you check that this particular field is, this particular set is a field? I'm here defining the operators a plus ab as a plus b mod 5. Similarly, star ab a star b mod 5. Please prove with this definition of star, with this definition of plus, this set is a field. Prove it. Come on. Proved. Check all the properties. ये एग्जाम्पल थी उधर, आपने इंटरनेट से ये एग्जाम्पल चैट जीपीटी से ये लिखवाई थी, आपने सारा कुछ चेक कर लिया इसमें, एडिटिव आइडेंटिटी और वो सारा कोई कर सकता है इधर आके. चलें प्लस देख लेते हैं वन बाय वन. जस्ट लेट अस गो थ्रू. प्लस के एतबार से ये सारे क्लोज्ड हैं क्योंकि मैं दो नंबरों को ऐड करूंगा, जब मॉड 5 दूंगा तो इसी में आएगा. स्टार के लिहाज से क्लोज्ड हैं, एसोसिएटिविटी है, कम्यूटेटिविटी है, और एडिटिव आइडेंटिटी है हर एक की. एडिटिव आइडेंटिटी 0 है और मल्टीप्लिकेटिव आइडेंटिटी 1 है. अगर मैं 1 को किसी के साथ भी मल्टीप्लाई करूं, आई विल गेट द सेम नंबर. अगर मैं 0 को किसी में भी ऐड करूं, आई विल गेट द सेम नंबर. ठीक है जी. एडिटिव इन्वर्स है हर नंबर का. फॉर एग्जाम्पल 2 का मुझे एडिटिव इन्वर्स बताएं. एडिटिव इन्वर्स ऑफ 2, यानी एक ऐसा नंबर आपने बताना है जिसको मैं इसमें ऐड करूं तो आंसर एडिटिव आइडेंटिटी आए. माइनस तो नहीं है इसमें बेटे. 3 इज द एडिटिव इन्वर्स ऑफ 2. Yes, because 2 plus 3 becomes 5. 5 mod 5 will be 0. Tell me the additive inverse of 4. 1. So for every number there is an additive inverse. Yes. Tell me the multiplicative inverse. Tell me the inverse, multiplicative inverse of 2. I mean multiply 2 with some number that generates 1. 3. Yes. Tell me the multiplicative inverse of 4. Multiplicative inverse of 4 is 4. 16 mod 5 is 1. So that's a finite field. Make sense? Yes? Okay. You have now 15 more minutes to understand the following. And this time I will take and I will check the quiz. What are the 10 properties? What are the 10 properties of a vector space? दो प्रॉपर्टीज थी जो मैंने लास्ट टाइम आपको कराई थी. इन जनरल देयर आर 10 प्रॉपर्टीज ऐसी हैं, क्लोजर, जीरो एलिमेंट, ये इस तरह की सारी हैं. ठीक है, उनको देखें. वेक्टर स्पेस क्या होती है, उसके 10 एलिमेंट्स कौन से हैं, और फिर अगला सवाल है फाइनाइट वेक्टर स्पेस क्या होती है. ठीक है जी, you have 15 minutes, your time starts now.